proposed design. This review highlights the overall mechanism of our project. Our rail-mounted carrier system simplify the harvesting process for farmers. They only need to push the carrier along the rail during harvesting, picking the produce and placing it into the carrier as they once move along the road. Once harvesting is complete, the farmer pulls the carrier back to the starting point to unload the containers attached to the carrier efficiently. This design streamlines the workflow and minimizes effort throughout the harvesting process. Now, this is the pesticide system design concept. Here we can see that the pesticide is stored in an elevated tank and flows into a centrifugal pump. The flow is controlled by a solenoid valve, which, when programmed to open, allow the pesticide to pass through and reach the sprinkler system. The main pipe use 25 mm HDPE to regulate the flow rate, while the LDPE pipes are used for the sprinkler connection. The fogging sprinkler has a coverage radius of approximately 3 meters, ensuring efficient pesticide distribution. Now,
The suitable material of the angle bar and hollow cylinder for carrier and rail part is my steel. Initially, the consideration has been made by comparing with other materials such as aluminium and stainless steel, but based on the cost and safety of factor consideration, mild steel will be a suitable material with FOS 2.22, not less than 1.5 or more than 2.5. By calculation, safety factor of aluminium is 1.42, which less than 1.5, while stainless steel is 2.87, which will be overkill in terms of its strength. As for the cost, stainless steel will be not too costly compared with my steel, even though my steel has a pass in terms of FOS. By consider safety factor from binding stress and cost of each material, choosing mass steel will be a best material selection for Edison Harvest Pro.
For our fluid analysis, the pressure losses in the pesticide distribution system is calculated to ensure the pump can generate enough pressure to the whole greenhouse. So for our piping system, there are two types of pipes that we use, which are the HDPE pipe and also the sprinkler pipe. The total number of sprinklers that we use in the greenhouse are 308. Moving on to the calculation, the parameters that we calculate for the pipes and also the sprinkler head are the average velocity, the Reynolds number to see whether the flow is laminar or turbulent, the frictional factor, the head loss and minor losses, and also the total pressure drop. After doing our calculation, we have found that the total pressure drop for our system is 59 kilopascal. The pump that we have selected is the 5 horsepower horizontal centrifugal pump from the manufacturer Atto, where the power consumption of this pump is 24 kilowatt per hour and the efficiency is 45%. The pressure generated by the pump is 152.67 kilopascal, which means that it exceeds the total amount of pressure drop that we have calculated before. This means that it can generate enough pressure to the greenhouse. For our thermal analysis, since our pump is located outside of the greenhouse, it is exposed to direct sunlight and can cause overheating. So this is why we constructed a pump house to protect the pump, and the dimension of the pump house is 360 times 500 meters and the material of the roof is zinc. The heat factors calculated are the heat dissipation and the heat gain. The result of the calculation is that the total heat dissipation exceeds the total heat gain, so it is within the safe temperature limits. This means that no active ventilation, such as fan, is needed for the pump.
All right, next we focus on the mechatronic part. First thing is the flow charts of the prototype system. Our group considered to choose pesticide system as the automatic system. Otherwise, for the harvesting and the transportation, we've done it manually. Let me explain briefly about the flow charts. Basically, our system has its own requirement. The requirement is referring to the water level inside the pesticide tank. If it's below the requirement, the system will not operate. And if it's above the requirement, the system will operate. So basically, that's the system of pesticide. Okay, so this is the system configuration of our pesticide system. As what you can see, we have zero point 0.5 horsepower water pump and also the solenoid valve. Both components require AC current and supplied it from home, approximately 240 voltage. We also include the miniature circuit breaker MCB for safety purpose. For Arduino Uno, we power it by using 9-volt battery, and the bus bar is used as a terminal for live, earth, and ground wire. Not to forget the solid state relay SSR, which function as a switch. And lastly is the ultrasonic sensor. It's used for object detection. Lastly, from the mechatronic part, I'd like to share you several advantages of the system. First is it's cost effective, where we don't require much labor cost. Second, in terms of safety awareness, the alarm system allow the user to alert whenever the system is in operate. Third, it's increased the efficiency, where we don't require much time and energy compared to the traditional spraying method. And lastly, it's apply the sustainable farming practice, where we utilize the resource efficiently and reduce the chemical waste.
For manufacturing, two subsystems of harvesting system will be manufactured in our plant, which is carrier and rail. For pesticide system will be outsourced from sub-company. The process flow to manufacture our product is shown in the slide. Our plant will utilize job shop with process layout to cooperate customization of our product. Job shop with process layout is chosen because it is a flexible production system that is ideal for a low production quantity and customized product. Our material handling system is forklift, as lifting heavy items such as steel manually may cause injuries. Drawer storage system will be utilized in our plant to store items for assembly such as M10 eyeball. This is to reduce cycle time. Total processing time for one unit, which consists of 3-meter rail and a carrier, is 4.3 hours. This is make monthly production is 37 units and yearly production is 444 units. For cost analysis, the total cost is total fixed cost added with total variable cost. Selling price for one unit of our product is Rm 8,848 ringgit and 50 cent. The calculated break-even point is 274 units. Economic efficiency is 115.6%, while benefit cost ratio is 7.2. All of this is shown in the table on slide. Our selling price will comprise 20% profit rate and 10% of SST. In order to gain profit, we need to sell 247 units as shown in the break-even analysis. This production system is efficient and profitable as economic efficiency is greater than 100%. The production will achieve economic sustainability and result in positive net benefit as benefit cost ratio is greater than 1.
Let me briefly walk you guys through the three key procedures for ensuring safety and efficiency of our product. Firstly, after the misting process, fruit can only be harvested after a minimum of 3 days. Additionally, workers are only allowed to enter the greenhouse 30 minutes after the misting process is complete to ensure their safety. Secondly, before starting, workers must inspect the carrier and rails. It's also mandatory for all operators to undergo proper training to safely handle and operate the harvesting equipment. Lastly, to prioritize safety, all workers must wear the appropriate personal protective equipment (PPE) as outlined in the manual, including gloves and safety boots. By adherence to these guidelines, we can maintain a safe and effective working environment.